అవుతుంది మ్యామ్. స్క్రీన్ షేర్ చేయండి.
Sorry. Once again, a very good morning to all of my students. In yesterday's class, we discussed about what are the uses of computer networks like business applications, home applications, mobile users. And at the end of the class, we also discussed about what are the social issues that are associated with computer networks. In today's class, we will discuss about what are the technical issues that are involved in the designing of a computer network. There are no hard and strict rules that a particular computer network has to be used in a particular application. There are so many types there. So which one has to be selected depends upon the application we want. And the money matters, everything has to be considered, and we have to select a particular type of computer network for particular application. But there are two dimensions that are very important in designing of the networking hardware. Those two are, first one is transmission technology. So there are two dimensions that stand out as important. They are, first one is the transmission technology and the second one is the scale. First, we discuss about transmission technology. So what type of technology is to be used for transmission of data in the computer networks? Here, the transmission technology is broadly classified again into two types. First one, broadcast links, and the second one, point-to-point links. First, we discuss about broadcast links. So, broadcast links are having a single channel. Remember here, broadcast links or broadcast networks, both are synonymous. So, broadcast networks consists of a single channel for communication, and it is shared by all the machines on that network. For example, if in the network there are 100 systems, 100 computers or machines, we can use any word. So if in a network there are 100 machines, say 1, 2, 3, 4 like that, 100 machines, if the machine 1 sends a message, that message is received by the remaining 99 machines numbering from 2 to 100. I think all of you clear? So a broadcast link consists of only a single channel for communication, and at a time only one channel can send messages, and all those messages are shared by the remaining computers on that network. Here, what we send through these machines is short messages. So these short messages in this context are called as packets. Okay, packet is nothing but a short message. So if machine 1 sends a packet, then the remaining 2 to 100 numbered machines, remaining 99 machines receive that messages. But which machine has to respond? In the packet, there is an address field in which it specifies which machine has to be respond. Okay, for example, I had already told you, if in a network there are 100 machines, if the machine 1 sends some packet in the address field, if it specifies the particular recipient, for example, 50 machine has to respond, then this packet is received by the remaining 99 machines. All the 99 machines receive that packet and view that packet, but the address in the specific address field, the specific machine 50 will reply to that packet. Okay, the same thing here I am explaining once again. So short messages called packets sent by any machine or received by all other machines working on that network. So here what happens, I will give one best example. If there is some railway station, in the railway station all the passengers are waiting for their trains, but the announcement is given that at 3:30 p.m. Konark Express will arrive onto the platform number 3. Okay, so the announcement is like this. This announcement is heard by all the passengers in the station. Okay, so here the announcement is the mission 1 on the network and the passengers on in the station are the remaining missions. So who will respond? Those passengers who want to travel in the Konark Express at 3:30 p.m. will respond and move forwards to the platform. So that is the example here. So even though any machine, if there are 100 machines, any machine can send the information, but it is received by the remaining all machines working on that network. But in the packet, there is an address field and there is the specific machine's address is specified there, and that has to respond. Okay, clear? Next, when a machine sends a packet, the remaining machines receives that packet and checks the address field. If the packet is intended for the receiving machine, it responds, and other machines just ignore it. That is about broadcasting networks. And there is some type of broadcast networks also send the address field in the packet with a specific code. They follow some specific codes. So when the packet is received by the remaining machines in the network, what they will do is they receive it and process it by the every machine. Because here in the address field, the intended receiving machine receives the information in the form of a code. So after receiving the packet, all the remaining machines work on it and they process it. So this mode of operation is called broadcasting. Okay, broadcasting means if a broadcasting network sends a packet with an address field with a specific code, and if the remaining machines process that code, this process is known as broadcasting. Okay, so this is all about broadcasting links. And one more important thing is I had told that there is only single channel for communication and only one channel can send the message and the remaining machines can receive the message. But there is some flexibility that some broadcast systems send a message and only a subset of machines can receive. Only a subset of machines can receive that message. That is known as multicasting. Broadcasting means processing of a code in the packet, and multicasting means only transmits the messages to a subset of the machines working in the network. I think all of you are clear about broadcast links. So now we move on to point-to-point links. Point-to-point links, in contrast to broadcast links, it consists of many connections between individual pairs of machines. So in broadcast networks, there is only one channel, but in point-to-point point-to-point networks, there are so many connections. For example, for simplicity, let me consider only 3 machines. There is an individual connection between individual pair of machines. Machine 1 and machine 2 is one pair. There is an individual connection between these 2 machines. Similarly, there is an individual connection between the machines 2 and 3. Again, there is an individual connection between the machines 1 and 3. So there are so many number of connections between the machines that are working on the network. So due to this, what happens if machine 1 sends a packet to machine 3? The main purpose of the machine 1 is to send the message to the machine 3. But in between, what happens? It has to visit the intermediate machines also. It has to visit intermediate machines and it reaches the destination. The same thing I am explaining in the PPT also. So once go there. Point-to-point network consists of many connections between individual pair of machines. A packet to go from a source to a destination in this type of network may have to first visit one or more intermediate machines. So I am simply saying 3 machines. If there are 100 machines, if a machine 1 sends an information, if it is a source and the destination is the 100 machine, then it has to visit intermediate 1 or 2 intermediate machines also. But what route is best one, which length is possible, so we have to select, we have to look at that which one is important and have to select the particular network. So generally what we can say that broadcast networks are suitable for smaller geographically localized networks, and point-to-point contact is used for larger geographically localized networks. So for smaller networks, we use broadcasting links, and for larger localized areas, we use point-to-point contact links. Next, here there is the term unicasting. Unicasting means even though there are so many connections, even though there are so many intermediate machines, sometimes it is possible that there is only one sender and one receiver in point-to-point network. So that is known as unicasting. So from these broadcast links and point-to-point links, you have to remember 3 main terms. First one is broadcast link consists of only one channel for communication, and the second thing, broadcasting. Broadcasting means if one machine sends a packet, if the address of the destination machine is in the form of a code, the received machines processed that code. So the process of decoding is called as broadcasting. Again, multicasting. Multicasting means even though there is a single channel, and once when a machine sends a message, if it is shared to all the machines on that network, sometimes it is possible to send that message only to a particular subset of machines on that network. So that is known as multicasting. In point-to-point contacts, even though there are so many number of connections, sometimes it is possible that there is only one sender and only one receiver. So it is known as unicasting. So what I had initially said that there are 2 points we have to consider. First one is the transmission technology, and second one is the scale. Scale means range. So what type of network we have to select depends upon the geographical localized area. So depending on that, the following table is framed. So once we can go through that. An alternative criterion for classifying networks is by scale. Distance is important as a classification metric because different technologies are used at different. So once go through the table. Vineet, కనిపిస్తుందా table? Vineet?
Yes, ma'am. Yes, ma'am. Yes, ma'am.
Okay. So,
కనిపిస్తుంది.
okay. So here the network classification is done on the basis of 2 categories. First one, transmission technology, and second one, the scale. So first look at the here. Inter-processor distance, and second one, processors located in same, and example. We will discuss one by one. So if the inter-processor distance is 1 meter, that means if the processors are located in the same square meter, here the geographical area of the network is only 1 square meter. So in that cases, the computer network used is called personal area network, simply PAN, PAN, personal area network. If the processor is located within the range of a square meter, the type of computer network used is personal area network, simply PAN. If the inter-processor distance is 10 meters or 100 meters or up to 1 kilometer, that is, if the processors are located in the same room or in the same building or in the same campus. If the different machines are located within a room or building or campus, then which type of network is used here? It is a local area network, LAN, L-A-N, LAN. If the interprocessor distance is 10 kilometers and the processor is located in the same city, within the city, So then metropolitan area network, simply MAN, metropolitan area network type networking is used. Next, if the interprocessor distance is ranging from 100 kilometers to 1000 kilometers, that is, if the processors are located inside the country or inside the continent, so for that, the best suitable computer network is wide area network, WAN. And finally, if the interprocessor distance is 10,000 kilometers and the processors are located in the same planet, that means wherever on the earth, okay, you can use the network, that is the internet. So here the classification is based on the scaling, basing on the geographically located distance of the machines. So for small area, very small area, for a personal area within 1 square meter, we use personal area network, simply PAN. For the distance, for the processors to be used in a room or building or campus, we prefer local area network, simply LAN. For cities, we use metropolitan area network, simply MAN. For machines inside a computer and a continent, we prefer wide area network, simply WAN. And on the whole earth, for the communication, we use the internet. So we will discuss one by one. First, we discuss about the personal area network, simply PAN. So this is personal area network. Personal area network means it provides the devices to communicate over the range of a person. First, I will read what is in the PPT and I will explain. So a personal area network, PAN, is the smallest network which is very personal to a user. This may include Bluetooth enabled devices or infrared enabled devices. PAN has a connectivity range up to 10 meters. PAN may include wireless computer keyboard and mouse, Bluetooth enabled headphones, wireless printers, and TV remotes. Okay, now I will explain. So I had already told you, once go back to the table. So look at here, personal area network. So the interprocessor distance is 1 meter and the processor is located in the same square meter. So see how much small area it is. Here, the personal area network is able to allow its devices to communicate just over the range of a person, only around the range of the person within square meter. One common example of this personal area network is a wireless network that connects a computer with its peripherals. So the peripherals may be keyboard, mouse, printer, headset, whatever may be. So the wireless computer network with its peripherals is a good example of this personal area network. We all know that almost every computer has an attached monitor, keyboard, mouse, and printer. If we doesn't use wireless, then there may be separate wire for the keyboard, there is separate wire for printer, there is separate wire for mouse. Okay, so there are so many number of cables. If someone is a new user of the computer, then he will get confused to which wire has to be plugged into the socket, like that. So in order to avoid that problem, these computer vendors designed a new device, that is Bluetooth. Okay, so the best example of the personal area network is Bluetooth. So most of the so this Bluetooth device is a short range wireless network, and this Bluetooth connects the components of the the accessories of the computer like the printer, keyboard, mouse, etc. without wires. It replaces all the cables. If our devices have Bluetooth, then there is no need for us to use the cables. We just put the Bluetooth on and all the devices work together. So simple chapalante, the Bluetooth uses the master slave type pattern. When the Bluetooth is on, the Bluetooth, when the Bluetooth is on, then the system will become master, and the keyboard, printer, mouse all becomes slaves, and whatever the master talks, the slaves just follows the rules of the master. So what type of addresses are to be used, when they have to broadcast, how long they have to transmit, what frequencies are to be used, like that. Here, all these peripherals will follow the master's rules. So Bluetooth is not only used for this communication, for this simple purposes, but it is also used in medical applications also. A PAN is formed with an embedded medical device such as pacemaker, insulin pump, or hearing aid. We can use for those applications also Bluetooth. So embedded systems connected with these applications are used in the medical fields. Not only that, when these PANs are used with RFID, other technologies, RFID on smart cards and library books also, it is very useful. So these are the various applications of the personal area network, and you have to remember is the best example is the Bluetooth. So next we will move on to the next type of network, that is local area network. Local area networks are privately owned networks within a single building or campus of up to a few kilometers in size. Once again, go back to the table. So look at here. So this is the second level of the network. If the interprocessor distance is 10 meters to 1 kilometer, and if the processors are located in the same room, building, or campus, then we prefer the local area network. So commonly, local area network is used for educational institutions, small offices, next to small factories. In that fields, in that organizations, we prefer local area network. So this local area network is used to share resources and for exchanging of information. I had already told you in 2 days classes onwards, I am saying what are resources. Resources may be hardware, maybe software, maybe data. So here, especially resource means printers. So I had yesterday also, I had told you, in an organization, for example, in our department, if there are 60 members, if they are having 50 or 60 desktops or computers, they need not to purchase 50 printers. There is no necessity for each computer. There should be a separate printer for each computer. Okay, they can share. Even though there are 50 computers, they can share a single printer. So in order to share the resources and for exchanging of information, local area network is used in organizations and small companies. Okay, next. LANs are distinguished from other types of networks by three characteristics. So there are different types of networks are there: PAN, WAN, LAN, MAN. So how can we distinguish a LAN from other networks? So we can distinguish by three characteristics. First one is their size. Second one, their transmission technology, and third, their topology. Okay, so coming to the first one, size, the size of LAN is small. Second one, the transmission technology used in LAN is wired technology. There are also again wireless technologies, but at present we'll discuss about wired technology, wires. And next one is their topology. Topology means the way in which the machines on a network are connected with the cables. If the computers are connected with the cables linearly, it is a bus topology. If it is connected in the form of a closed loop, it is a ring technology. If there is some center point and all the machines are interconnected with that center point, it is called a star topology. Okay, I will show you. Next, So these are the different types of topologies. Functions of, I am not showing the diagrams because the time will be running out. So we will see the functions of LAN. The main functions of the LAN local area network is file serving. It is used to share the files, used to serve the files, and all these files are placed on a large local disk drive. So that large local disk drive acts as a central storage repository. Whatever the file we have to share, that is deposited on the central storage repository. Next, print serving. It is used for print serving. That means it provides authorization to access a particular printer. Next, third function is video transfer. High-speed LAN area local area networks are capable of supporting video images and live video transfer. It is used in manufacturing support. So if it is used in plants, if it is used in industries, it supports the computing network and makes the things easy in industries, and thereby making the manufacturing support. And academic support. Academic support means LANs are used in educational institutions like ours. So in order to exchange of information, in order to exchange of resources. And it also provides email support. Coming to the advantages, first advantage is individual workstations might survive network failure. So if there is some network failure, so there are so many number of machines, so they can restore that network failure, because there are not one or two, there are so many number of machines. Next, second one, component and system evaluation is possible, and we can access other LANs and WANs using this LANs technology. And coming to the disadvantages, equipment and support can be costly. It is a costly setting of a LAN is not a simple thing. It deals with money. Money matters here. Next, some type of hardware is not compatible. So all computer networking is not possible with all hardware. So the hardware is compatible only to some types of networks, and LAN consists of many links. So one thing, I want to share another slide. So look at here. So in an organization, how the LAN network is set up. This is the diagram showing that. So here, this is the bus topology. Bus topology means the cable connecting the different machines on the network linearly. Okay, so here the computers, here the data can be transferred in bidirectional. Here, once a message is sent by a machine, the other machines acts as slaves, and they are not able to send a message. Once again, I'm repeating. So in bus topology, only one machine can send an information at one time, and if the other machines try to send messages at that time, they become a conflict. Okay, there become a conflict. To resolve that conflict, Ethernet is used. If Ethernet is used, then even the two machines simultaneously sends a message, the other machine will remain silent for some time, and again it retries if there is a conflict. So in bus topology, Ethernet is used, and in the ring topology, IBM token is used. Here, the bus topology is used in one building of the institution, and ring topology is used in another building in the same institution. So here, this bus topology is connected to the ring topology by means of a central unit, that is a bridge. That bridge may be either a switch, or it may be hub, or it may be a router. So here, this bridge connects one building, the machines in one building with the machines in another building in the same institution. So here, the buildings in the machines in one building may be connected in bus topology, and the machines in other building may be connected in ring topology. Whatever may be the topology we use, but the bridge connects the two different types of topologies in the same institution. So finally, I will go through what are the points we had discussed here. So up to now, we had discussed that in the designing of the computer network, we have to consider two things. One is the transmission technology and the second one is the scale. So transmission technologies of two types, broadcast links and point-to-point links. And in the scale, it is divided into personal area networks, local area networks, metropolitan area networks, wide area networks, and internet. So we discussed about the personal area networks. The personal area networks is confined to a person. So the best example of the personal area network is the Bluetooth. Next one is local area network. Local area network is the network that is preferable for institutions, small companies, and factories. So it is a privately owned network. So it is the LAN is distinguished from other computer networks by three characteristics. First one is their speed, their size, their topology, and the next one their transmission technology. So size is very small, and coming to the transmission technology, it uses wired technology. And coming to the topologies, there are three types of topologies: bus topology, ring topology, and star topology. Okay, so here in an institution, different types of topologies in one institution are connected with another machines in another building through a bridge. That bridge may be a hub switch or a router. Okay, so there are so many advantages of the LAN, but there are also drawbacks. So those drawbacks are it is very cost effective. Next one, some hardware will not support it. So these are all the drawbacks, but there are more advantages of using this LAN network. Okay, so with this, I am concluding this class. So thank you all. You can leave the meeting.
Ma'am,
Chapama.